Have you ever thought about how secrets were kept in the ancient world? I mean, long before we had digital encryption, leaders still needed a way to send messages that their enemies couldn't possibly read. Well, today we're going to dive into one of the most famous ancient codes, talk about the brilliant mind who finally cracked it, and see how a really simple pattern, one that was hidden in plain sight, completely changed cryptography forever. So our story kicks off with one of the most powerful figures in all of history, Julius Caesar. As he's leading his armies across Europe, he's got this huge problem. How do you send military commands without the enemy intercepting them and figuring out your next move? His solution was honestly pretty elegant, and for a very, very long time, it was totally unbreakable. And that really gets us to the heart of the mystery, right? How did this thing actually work? What made it so good for so long? And maybe the most important question of all, what was the tiny clue, that one hidden weakness, that eventually brought the whole thing crashing down?
Okay, so let's start by looking at the cipher itself. Because to really understand how it was broken, you first have to appreciate how clever it was. Caesar needed a method that was super easy for his generals to use, but an absolute nightmare for anyone else.
So what he came up with is what we now call the Caesar cipher. It's a type of substitution cipher, which sounds kind of technical, but the idea behind it is beautifully simple. You just take the regular alphabet and, well, you just shift it over. Here's exactly how it works. Let's imagine you've got two people, we'll call them Alice and Bob. First, they secretly agree on a shift number. Let's just say they pick the number 3. So now, to write a secret message, Alice replaces every letter in her message with the letter that's 3 places further down the alphabet. So A becomes D, B becomes E, you get the idea. When Bob gets the message, he just reverses the process. Simple as that. And you can see right away how effective this is. The simple word attack turns into this meaningless jumble DWWDFN. Now, if you're an enemy soldier and you get your hands on that, it would just look like complete and utter nonsense.
And the crazy thing is, it worked. It worked so well, in fact, that different versions of this basic technique were used by armies for centuries after Caesar. For a very long time, if you didn't know that secret shift number, you were just completely locked out. There was nothing you could do.
But, no code is perfect. Every secret has a weakness, kind of like a loose thread that if you just pull on it, the whole thing can start to unravel. So now our story shifts from the person who made the lock to the person who figured out how to pick it.
This is a pretty fundamental rule in all of security and cryptography. A codebreaker doesn't waste time trying to break the strongest part of a code. No, they look for that one single overlooked flaw. And the Caesar cipher, it turns out, had a very human flaw. So this is the million-dollar question, isn't it? I mean, if there are 25 possible shifts, you could just try every single one, but that's going to take forever. A real codebreaker doesn't guess, they deduce. They find a clue that points them straight to the answer. And here's the big twist in the story. The weakness of the Caesar cipher wasn't mathematical. It had nothing to do with the encryption method itself. The real secret to breaking the code was hidden in the predictable, consistent patterns of human language.
It turns out that every single language has its own kind of signature, a unique pattern that all of us leave behind whenever we write or speak, and we don't even realize we're doing it. The best way to think of it is like a fingerprint.
So this linguistic fingerprint is all about letter frequency. See, in any language, some letters just get used way, way more often than others. And this isn't random at all. It's actually a super stable and measurable characteristic of the language itself. So, take a look at the fingerprint for English. If you were to analyze any huge chunk of English text, a book, a bunch of articles, whatever, and you just count up all the letters, you will almost always find that the letter E is the most common one, by a long shot. Then you've got letters like T and A, which are also pretty frequent, while letters like Z, Q, and X are super rare. This pattern is incredibly consistent.
So how in the world does this fingerprint help us crack a military code that's been around for centuries? Well, this is where our hero, the codebreaker, steps into the story and connects these two big ideas.
So fast forward nearly 800 years after Caesar, an Arab mathematician named Al-Kindi has this incredible insight. He realizes that even when you scramble up a message with a cipher, you don't actually erase that linguistic fingerprint. You just shift it. All right, so picture this. A code breaker intercepts a really long encrypted message. They do the same thing we talked about. They count up every single letter and make a frequency chart. And in their chart, they see that the most common letter in this secret message is the letter H.
Now here comes the big aha moment. The code breaker knows that in any normal English message, E is supposed to be the most common letter. But in this secret message, H is the most common. The fingerprint is still there, it's just been moved down the alphabet.
So the only question is, how far has it moved? Well, let's just count. From E to H, let's see, F is 1, G is 2, H is 3. That's it. The shift, the secret key that protected Roman military secrets for so long, is almost certainly the number 3. And just like that, the lock is broken. This simple observation had a massive impact. Not just on the Caesar cipher, but on the entire world of cryptography from that day forward. This brilliant technique that Al-Kindi figured out, we now call it frequency analysis. It's basically the art of breaking codes by studying the statistical patterns of the language they're written in. This discovery was a huge turning point. It pretty much meant that any simple substitution cipher, any code where you just swap one letter for another, was now totally vulnerable. The great race between the code makers and the code breakers had officially begun. And it really leaves us with a fascinating thought. Al-Kindi's method of finding a hidden pattern in language, well, that's the same core idea that drives so much of our modern world today, everything from data science to artificial intelligence. It really makes you wonder, what other invisible fingerprints and hidden patterns are out there all around us, just waiting for someone clever enough to find the key?